All right, Honors Algebra 2 and Algebra 2, welcome to your Chapter 8 game plan, page 7 again, part 2 video here. So we're just going to pick up from the ones that we did in the previous video. Here's a little intro question, folks. If I had x over 4 plus 3 over 4 equals 11 over 4, what would you tell me x equals? Hopefully you'd all say 8. Look at that. When all the denominators, now I don't have one fraction equals another fraction, so I'm not cross multiplying here. Okay, but when all the denominators are the same, then the numerators have to make an equivalent statement, right? We got to have equality up here. So x plus 3 is equal to 11. That's the name of the game there. When the denominators are equal, then the numerators have to make this true statement. X plus 3 equals 11. So x would be 8. I would drop the denominator. I wouldn't care about the denominators when they are all equal. So that's kind of what I'm trying to do here on 16. So here is 16. I'm going to highlight what it is. We have 10 questions in this video, and then we'll be good. So what you want to do is you want to make all the denominators match up. Well, first off, x doesn't have a denominator, so call it x over 1. Now, both of these fractions, x minus 2, x minus 2, they both have x minus 2. So what are you going to give this x? We talked about it in a few videos ago when we added or subtracted those rational functions. You're going to give this first x in the numerator x over 2 and in the denominator x over 2. Okay, then all the denominators are the same. X minus 2, x minus 2, x minus 2. And just like up before, when all the denominators are the same, all I care about are the numerators now. Okay, so I can drop the denominators, and now I know that this plus 10 is equal to x squared plus 3x because all those denominators are the same. So I distribute x squared minus 2x plus 10 is equal to x squared plus 3x. Again, bye-bye denominators. X squareds cancel. That is lovely. Bye-bye. Negative 2x plus 10 is equal to 3x. Add 2x to both sides. You get x equals 2. Or does it equal 2? This is going to happen several times today. Now, in the other video, it said check your solutions. Folks, when you plug 2 back into your original equation, you get 10 over 0 is equal to, what is that going to be? Another 10 over 0. You can't divide by 0. That's a no-no. This is an example of an extraneous solution, a solution that you get that makes that initial equation invalid, undefined. So the final answer is actually no solution. All right, I should make that a better, you know what I mean, no solution. There we go. Final answer is no solution. That might happen a few times here. All right, here is number 23. Okay, here is the original one. Our goal is to factor everything. X plus 2 has been factored, x minus 2 has been factored, but x squared minus 4 is x plus 2, x minus 2. Now, this has x plus 2 in the denominator. This one has x plus 2 in the denominator. So what are you going to give 5 over x minus 2? Top and bottom get that x plus 2 that denominator is missing. This fraction here has an x minus 2. This fraction here has an x minus 2. This fraction does not. So this first fraction is going to get a 2x minus 2, both north and south. And folks, all the denominators are now the same. X plus 2x minus 2, x plus 2x minus 2, x plus 2x minus 2. So I can get rid of the denominators because I now know that this plus this is equal to 6. So a little distribution, that's going to be 4x or 2x minus 4 plus 5x plus 10 is equal to 6. Combine the x's. 2x and 5x is 7x. Negative 4 plus 10 is 6. Subtract 6 from both sides, you get 0. Go back to that original. Everything's good. I can plug 0 in there and I won't get 0. If I plug 0 in there, I won't get 0. If I plug 0 in that denominator, I won't get 0. All right, so x equals 0 is a good, valid solution. All right, that page is done. Let's keep going. The 24 here. This one's not too bad. Here's my original equation. So first off, I'm going to call it 5 over 1. 5 over 1 plus 5 over x equals 6 over 5x. This doesn't have anything, it just has 1. What do I need? So first off, x. This one's going to need an x. But also 5x, single x, single x. The two fractions on the left side both need to be multiplied by 5. Now all the denominators are 5x, 5x, 5x. So I can get rid of the denominators. I know that this plus this is equal to this. So 5 times 5x is 25x. 5 times 5 is 25 equals 6. Subtract 25 from both sides and divide by 25. There you go. Negative 19 over 25 is a perfect answer. All right. Get those denominators to match up. Now, if you wanted to, you could just add 4 on this one and then cross multiply. Or you can call this 4 over 1. Now I'm looking for the common denominator of 2 8s and 1. The lowest common denominator is going to be 8. Multiply this by 4 over 4. Multiply this by nothing, 1 over 1. Multiply that by 8 over 8. Now all the denominators are 8s. And this is great. 7 times 4 is 28 equals 7x minus 4 times 8 is 32. 28 equals 7x minus 32. Add 32 to both sides, divide by 7. 60 divided by 7 is your answer. Okay, on this one, you could actually just move this over, move that over. You can move that over. You could, if you wanted to, just cross multiply. You can just subtract 5 from both sides. In fact, that might be quicker. But what I did is I put that over 1, 5 over 1, put that over 1. I multiplied this by x plus 1 over, x plus 1. Now that denominator has an x plus 1. And I multiplied this by x plus 1 over x plus 1. Now all the denominators are the same. X plus 1, x plus 1, x plus 1. Time for a little distribution. 5x plus 5 minus 4 equals 6x plus 6, which is over there. 5 minus 4 is 1. Subtract 5x from both sides. You get x on the right side is equal to, subtract 6 from both sides, negative 5. X is equal to negative 5. All right. Let's take a look here at one just like it. X over 3 plus x over 2 is 10. I call this 10 over 1. A few different things we can do. First off, you could do a little cross multiplying. I think I switched it up here. 3 and 2, the common denominator there would be 6. So 2x plus 3x all over 6 is equal to 10 over 1. All right. 5x over 6 is equal to 10 over 1. Okay, just showing you that you can also cross multiply in some of these. 5x equals 60, x is 12. On 32, here is the original. I'm going to call it 4 over 1 plus 2y over y minus 5 is equal to 8 over y minus 5. Y minus 5, y minus 5. This needs a y minus 5. Going to distribute 4y minus 20. All the denominators are now the same. Y minus 5, y minus 5, y minus 5. So I got 4y minus 20 plus 2y equals 8. 4y and 2y is 6y. Add 20 to both sides. Divide by 6. 14 over 3, or 4.6 repeating. And for our last few here, you have 3y over 5 plus 1/2 is equal to y over 10. And I didn't do anything but rewrite it. Common denominator here would be 10. So multiply that first fraction by 2 over 2. That second one by 5 over 5. Y over 10 doesn't need anything. Now all the denominators are 10. That is a 10. That is a 10. That is a 10. So 6y plus 5 is equal to y. Subtract 6y from both sides. Y is a -1 when you divide. Okay, now that was 33. I've gone out because these last ones, we got 2 more. Just take a little bit of work. I know I've gone out of order. It's no big deal. I know how many questions there are, so that is just what I'm looking for, is how many questions you got. Make sure they all have the right work. 4 over x minus 3 is equal to 2 over x plus 1 plus 16 over something that can be factored. So what we want to do is we want to factor that. What multiplies 3 differs by 2, x minus 3, x plus 1. X minus 3, x plus 1 looks to be the common denominator. That has an x plus 1, so give it x minus 3 over x minus 3. That has an x minus 3. The other two have x plus 1s. So make sure it gets x plus 1 over x plus 1. Now all the denominators are the same. X minus 3, x plus 1. X minus 3, x plus 1. X minus 3, x plus 1. So the numerators make a true statement. 4x plus 4 is equal to 2x minus 6 plus 16. That is what's written there. Combine like terms, 2x plus 10. Subtract 2x from both sides. Subtract 4. You get 2x equals 6x is 3. Or is it? If you're going to take pre-calc and then calc eventually, you definitely need to understand this. So, folks, if I let x equals 3, here's a problem here. Plug 3 back into your original. If you plug 3 in that denominator, you get 4 over 0, which is undefined. That is a math sin. No, no, no. So, again, the real answer is no solution. All right, so that's the second one we have here, and it looks to be the last one. On 34. We have 7 over x squared minus 5x plus 2 over x equals 3 over 2x minus 10. This can factor. It's going to be 2 times x minus 5. That won't factor. And this can also factor. It's going to be x times x minus 5. So first off, x, this needs an x. That is an x, I promise. All right, what do we have here? X minus 5, x minus 5. This needs an x minus 5. And 2 doesn't have a 2, and the denominator doesn't have a 2. So this one will also get a 2 over 2. This one will get a 2 over 2. So all the denominators are the same. All the denominators are 2x, x minus 5, 2x, x minus 5, 2x, x minus 5. What we have here is 7 times 2, 14, plus, I just did the 2 times 2 part. Then you're going to multiply it by x minus 5 is equal to 3x. Okay, here's what we got. Now we can distribute 4x minus 20. Combine like terms, 14 minus 20 is 4x minus 6 is equal to 3x. Subtract 4x from both sides. Negative 6 equals negative x. X is 6, and that is okay. Invalid answers would be a what? Positive. If you got positive 5 for x or x equals 0, those would be undefined. But we didn't. We got x equals 6, and that is a good answer. Folks, that is the end of page 7 for you. There should just be 1 or 2 more videos that will conclude this game plan. This is Yak Math Videos, signing out.